Question number 6. It says a volume V of water is trapped in a fixed vertical pipe of a uniform section having a fixed partition C. With the help of three pistons P, Q, and R that can slide without friction. The piston Q and R connected to the ends of a light lever arm AB with the help of two vertical light cords. The lever arm has a fixed fulcrum that divides it in two portions of lengths L1 and L2 as shown in the figure. If the system is in equilibrium, find the height of the water column between the pistons P and R. So here this is fulcrum F, this is lever AB, and this is connected with the string with the two pistons Q and P, and there is a partition C. This is another piston R. Something is missing in this question, which has been updated later on. That one of the thing is that these pistons are light. That means they do not carry any mass. Second thing is that this piston P is having a cross-sectional area S. So the cross-sectional area of this P piston has been given as S. Because we need to give answer whatever the answer we are requiring for that sake, this is going to be required. So all the three pistons are light and the cross-sectional area of the piston P is S. So we can use this S for our answer purpose. The question is demanding for at equilibrium, what is the height between these two? So this quantity is something we are looking for. Let's call it to be H, and this H we need to find out. So the same picture I have drawn over here for sake of forces representation. So this height, which is H, we need to find out. Let's consider the gap between this P and Q pistons is H prime. And there is a tension on this string, let's say it's T1, and on the another string is T2, and this is R. And let's consider this cross section is S1, cross section of this piston Q, cross section of another piston P is S2. For us, S2 is given as S. So finally, we will replace S2 by S in our final expression. Moreover, there's this lever arm in which this T1 is going to act downward, T2 is going to react downwards, and it is at horizontal equilibrium condition. That means torque must be balanced about this F point. So we can write the torque equation T1 L1 must be equal to T2 L2. These T1 T2 are perpendicular to the this lever arm, so torque could be written like this, and they're equal. So that's one of the simple equation we can write immediately. Now we need to make a lot more equations for these different pistons. So one by one we will go. Force balance for piston Q. When we go for the force balance for this since this is light, so gravity force will not be there. Here will be pressure. Let's say this is one point that will have a pressure P1. So we will say this T force must be balancing the pressure forces, right? Outside is atmospheric pressure P0. So we can say that P1 minus P0, this is going to be P0, is equal to minus T by S1. If you are getting how I have written this, so you just multiply this by S1, this by S1, this by S1. So this is basically T. And this P1 S1 is the force in the upward direction, P0 S1 is the force downward direction. So net force in the upward direction is going to be P1 S1 plus T1. This must be equal to P0 S1. Then what I have done, divided by S1. So this becomes equation in terms of P's. So that's a P0. So that's one equation because of the force balance of piston Q. Similarly, we can have the force balance of piston P. So when we do this, so we can say P2 force must be balancing the atmospheric pressure and the resultant of this tension. So it's going to like P2 is equal to P0 minus T2 by S2. By the same logic, write the force equation, then divide by S2. For our piston, since it's massless and it is not connected with any string and other things, so pressure upside must be equal to the pressure downside. So P3 is equal to P0. These equations we are making due to equilibrium condition of these pistons, which are light pistons, right? Now, since we know this P3 could be written as in terms of P2, as P3 is equal to P2 plus rho GH. So from here you will find since P3 is P0, So P2 could be written as P0 minus rho GH, and we know P2 is already this. So these two are equal, which means T2 by S2 must be equal to rho GH, which says T2 expression is rho GH into S2. S2 is known to us. Now, once we know T2, we can also find T1 from there. So T1, T2s are now known to us in terms of H. Moreover, we need to use this 1 and 3 or maybe 1 and 2 together. So let's consider 1 and 2 together. So pressure of 2 minus pressure of 1 is going to be because of this height H prime, so rho GH prime. Now, P2 we know already is this. P1 we know already is this. We can subtract the two together, so that will come out as a T1 S1 minus T2 S2, P0 getting cancelled out. This came out to be rho GH prime. Now T1 could be written from here as T2 L2 by L1, so T2 L2 by L1 into S1 minus T2 by S2 must be equal to rho GH prime. We can take this T2 outside. So if we take this T2 outside, then you'll find it will be in the bracket L2 divided by L1 S1 minus 1 upon S2 is equal to rho GH prime. Now T2 is this expression rho GH into S2. Let's substitute there. And then this T2 goes inside, then you'll find it could be written as rho G getting cancelled out. And H can be divided from here. So right hand side will be H prime by H. S2 is getting in. So that is L2 S2 divided by L1 S1 minus 1. This 1 could be taken that side. So this is L2 S2 divided by L1, and this S1 can be taken that side, so it will be like S1 within bracket H prime divided by H plus 1, so that is H plus H prime by H. So this expression is going to be there. Now this is L2 S2. What is L2 S2? Let's think about. L2 is the length L2, S2, these are the basically length and the cross sections. S2 is known to us. Let's think about this thing. This is S1 within bracket H plus H prime. Now S1 is the cross section of this part. H prime plus H is the height. So cross sectional area into height, that gives this volume of this left portion. And total volume is given as a V. So we can say the volume of the right portion is going to be basically equal to V minus this, or we can say this volume of the left portion is going to be equal to total minus this volume. So total volume is given as a V, and this right segment is going to have a volume is equal to cross sectional area, which is S2 into height, which is H. So this S within bracket H plus H prime could be written as total volume minus volume of the right segment, which is S2 into H. So V minus S2 into H becomes this expression divided by H. Now we can further simplify it. It's like V by H minus S2. Now this S2 could be brought this left side. So we will have a V by H is equal to L2 S2 divided by L1 plus S1 plus this S2. S2 can be taken common. So it will be like L2 plus L1 divided by L1 into S2. You can check this calculation. I have done quickly. So from here you will find this H can be calculated. This H turned out to be VL1 by doing the cross multiplication divided by S2 within bracket L1 plus L2. But we know this S2 is what? S. So final answer is the height on this right side, that is between P and R pistons, is going to be equal to VL1 divided by S, the cross section within bracket L1 plus L2. So that's our final answer. Look at this. In this final answer, we require this S. And this S is the cross section area of this piston P. That's why I said this piston P's cross section area is not printed over here. Later on it has been updated. So this must be given to us. Moreover, the second point that I ask you to assume that these pistons are light, because we are not using the weights. Otherwise mgs will also play the role. So this becomes our final answer with the corrected version. Thank you.